Okay guys, so this first one, I'm not going to go over too much because I have videos already made about this, but I'll give you guys some hints and ones too. Remember that this is 2 meters up here. If you don't use 2 meters, it'll be impossible. Now, my first thing I would recommend doing, guys, making an x-axis right here. You know, you need that, and you'll figure out why you need that quickly, is that you need that to find your angles. So you need to find this. Let's call this T1, and this is going to be your theta 1, so you're going to have to find that. This is going to be T2, and this is going to be your theta 2. And all the way around, up, don't move it, this is going to be your theta 3. And we'll say that this is your T3. Now, the one cool thing to realize is that tension 3 is determined by the weight of this object. So T3 is going to be your FG. Theta 3 is going to be 270 degrees. 270 degrees. And then these ones, these two angles, you'll have to figure out using some geometry and trig. It's not too difficult. You'll have to divide this triangle in two. It's probably your best bet, and then find the angles. But make sure you keep your drawings very clear because you're going to need to make sure you get the proper angle with respect to the x-axis. And that's enough hints for that. Let's go and move on to the next one. This next one's a little bit more fun because we haven't done it before. Now we have this sign, and the sign is held up by a massless rope and a massless support beam. So here's our support, here's our rope. So that means we have a tension that goes up this way. Let's give this a tension, we'll call it just tension. And remember that tension's at an angle, so you have to find that angle, but I'll just help you guys out. Notice that it starts here at 0, goes over here, it stops here. Well, we don't really have a good reference for this angle, but notice if you go 40 degrees more, you'll end up at 180. So it's 40 degrees before 180, so I would call that 140 degrees. And then the next thing that is acting on this is going to be your force of gravity. That pulls this thing down. So here is your FG. And that's in fact given to you in the problem. When it gives you this right here, notice the units, be very careful. The units say 100 or 1,000 newtons, and that's telling you the weight of the sign. Okay, it's not the mass though. Okay, the next step is then to think about this support. Well, what the crap does this support do, Mr. Shaw? Well, notice if there was no support here, imagine the support wasn't here, this thing would swing. It would be almost just it would be what we call a pendulum. But this support prevents it from swinging, and this support just gives it a normal force. That normal force is going to be, oh, I thought I was using my arrow function. So the support's just going to make us go this way. It's going to give us you can call it a force applied, but I just call it a normal force. It's produced by the surface. So we've got these three forces, and notice guys, two of these are actually on the axes. So I'm going to go over to the other side and I'll actually set up this math for you. And once again, I like to go x's and y's. Divide by 2. So here we go. Let's do this as fast as possible. And you can always pause it. So remember, here there are angles. This one, our tension is at 140 degrees. So on the x side, you'll have tension x equals tension cosine 140 degrees. And on our y side, you'll have tension y equals tension sine 140 degrees. And then you'll notice that the force of gravity pulls you down, and hopefully you can see this as I go around 0, 90, 180, 270. The force of gravity is going to be at 270. So I'm going to write it up, but hopefully by now you'll realize that some of these are going to just simply cancel out. So your force of gravity, x equals Fg cosine 270 degrees, and Fg y equals force of gravity sine 270 degrees. Okay, and that's not too hard to do. Now let's go back and look at this one. Last one is the Fn produced by the support. Support's going to produce a force that pushes it this way. Once again, if the support is cut, you'd want to imagine that this thing would want to swing. So the normal force is going to produce a force pushing that way. It could also, you could call it a force applied, and it's going to be at 0 degrees. So, and hopefully some of you guys are like, this is also stupid as well, but I'm going to do it anyway. Fnx equals Fn cos 0 degrees, and Fn y equals Fn sine 0 degrees. Okay, so you've got your formulas. Now remember all the formulas in the x, so my F net x is the sum of all forces in the x direction, and it equals 0. And my F net y is the sum of all forces in the y direction, and it equals 0. So we've got these two formulas. We should be able to go at it now. Now remember, this is a stationary system. Look back at some of your other stuff. This is actually just like a problem we did the other week.